When dealing with a three-phase 208/4160 volts YY transformer, with both the primary and secondary wide points grounded and the secondary connection made at a bus breaker, the question arises whether a neutral conductor must be run with the phase conductors. In this scenario, the answer is no, it is generally not a requirement. The reasoning behind this lies in the grounding configuration and the principles of neutral grounding in electrical systems. The key factor is that the neutral point of the YY transformer is grounded on both the primary and secondary sides. This grounding ensures that the neutral point is already at ground potential. This is a fundamental aspect of grounded electrical systems, designed to provide a safe return path for fault currents, thereby facilitating the operation of overcurrent protection devices. The secondary connection is made at a bus breaker, which directly connects to the load. The neutral point of the load, if present, will also be at or near ground potential due to the system grounding. Because both the transformer neutral and the load neutral are effectively tied to ground, there is no necessity to run a dedicated neutral conductor with the phase conductors. The path to ground is already established and maintained through the grounding connections. Now let's consider the relevant code requirements. The National Electrical Code, (ONEC), is a widely adopted standard for safe electrical installations. The NEC does not generally require a neutral conductor to be run with the phase conductors for YY transformers when the neutral is grounded on both the primary and secondary sides. This is because the grounding system provides the necessary path for fault current return, ensuring safety and proper operation of the electrical system. The NEC mandates a neutral conductor to be run with the phase conductors primarily in scenarios involving Y-delta transformers or when the neutral is not grounded on the secondary side. In these cases, the neutral conductor is essential for maintaining a stable voltage reference and providing a return path for unbalanced loads. In a Y-delta transformer, the delta side does not have a natural neutral point, and the neutral conductor from the Y side is needed to serve single-phase loads connected to the Y winding. Similarly, if the secondary neutral is not grounded, a neutral conductor is required to establish a reference to ground and handle unbalanced loads. Understanding the NEC requirements for neutral conductors in different transformer configurations is crucial for ensuring safe and compliant electrical installations. Firstly, one should always consult the latest edition of the NEC and local electrical codes, as requirements may vary based on jurisdiction and specific application. Secondly, it's important to verify the grounding configuration of the transformer and the load to determine whether a neutral conductor is necessary. Thirdly, proper documentation and labeling of all grounding and bonding connections are essential for maintaining a safe and reliable electrical system. To further clarify, let's delve into the specifics of grounding and bonding in electrical systems. Grounding refers to the connection of electrical equipment and systems to the earth, which provides a low impedance path for fault currents to return to the source. Bonding, on the other hand, involves connecting non-current carrying metal parts of electrical equipment to create an electrically conductive path. Both grounding and bonding are essential for safety, as they help to minimize the risk of electric shock and fire. In the case of a YY transformer with grounded neutrals, the grounding connections at both the primary and secondary sides ensure that the system is effectively grounded. This means that any fault current will have a low impedance path to return to the source, causing overcurrent protection devices, such as circuit breakers or fuses, to trip and energize the circuit. The absence of a neutral conductor in this configuration does not compromise safety because the grounding system provides an alternative path for fault current return. However, it's crucial to ensure that the grounding connections are properly installed and maintained. This includes using appropriately sized grounding conductors, making secure connections, and regularly inspecting the grounding system for any signs of damage or corrosion. Let's explore different transformer types and their grounding requirements. Transformers are essential components in electrical power systems, used to step up or step down voltage levels to match the needs of different applications. There are several types of transformers, each with its own unique characteristics and applications. Firstly, there are single-phase transformers. These transformers are used in residential and light commercial applications where the load is relatively small and balanced. Single-phase transformers typically have a single primary winding and a single secondary winding, and they can be configured for different voltage ratios. Secondly, there are three-phase transformers. These transformers are used in industrial and commercial applications where the load is large and may be imbalanced. Three-phase transformers have three primary windings and three secondary windings, and they can be configured in various ways, such as Y-Y, Y-delta, delta-Y, and delta-delta. The choice of transformer configuration depends on the specific application and the voltage and current requirements. Y-Y transformers are commonly used for power distribution, as they provide a stable neutral point and can handle unbalanced loads. Y-delta transformers are often used for stepping down voltage from a high voltage transmission line to a lower voltage distribution line. Delta-Y transformers are used for stepping up voltage from a low voltage generation source to a high voltage transmission line. Delta-delta transformers are used in applications where a stable voltage is required, such as motor starting. Now let's talk about grounding requirements for different transformer configurations. As mentioned earlier, the NEC requires a neutral conductor to be run with the phase conductors for Y-delta transformers and when the neutral is not grounded on the secondary side. This is because the neutral conductor is needed to provide a return path for imbalanced loads and to maintain a stable voltage reference. For Y-Y transformers with grounded neutrals, the NEC does not require a neutral conductor to be run with the phase conductors, as the grounding system provides an alternative path for fault current return. However, it's important to note that some local jurisdictions may have more stringent requirements, so it's always best to consult the local electrical codes before installing a transformer. Next, let's consider the impact of unbalanced loads on transformer performance. Unbalanced loads occur when the current in each phase of a three-phase system is not equal. This can happen when single-phase loads are connected to a three-phase system, or when there are differences in the impedance of the loads connected to each phase. Unbalanced loads can cause several problems, including voltage imbalances, increased losses, and overheating of the transformer. Voltage imbalances can negatively affect the performance of sensitive electronic equipment, such as computers and process controllers. Increased losses can reduce the efficiency of the transformer and increase operating costs. Overheating of the transformer can shorten its lifespan and increase the risk of failure. To minimize the impact of unbalanced loads, it's important to distribute the loads evenly across the three phases. This can be achieved by carefully planning the load connections and using load balancing techniques. Load balancing involves adjusting the load connections to ensure that the current in each phase is as equal as possible. This can be done manually or automatically using load balancing equipment. In addition to load balancing, it's also important to use transformers that are designed to handle unbalanced loads. These transformers typically have a larger neutral conductor and a more robust core designed to withstand the effects of unbalanced currents. Finally, let's discuss the importance of regular maintenance for transformers. Transformers are essential components in electrical power systems, and their reliable operation is critical for maintaining power quality and preventing outages. Regular maintenance is essential for ensuring that transformers operate safely and efficiently throughout their lifespan. The maintenance tasks that should be performed on a regular basis include firstly visual inspections. These inspections involve checking the transformer for any signs of damage or deterioration, such as cracks, leaks, or corrosion. Secondly, there are electrical tests. These tests involve measuring the insulation resistance, turns ratio, and winding resistance of the transformer to identify any potential problems. Thirdly, oil analysis. This analysis involves testing the transformer oil for contaminants, moisture, and acidity to assess its condition and determine whether it needs to be replaced or reconditioned. Fourthly, bushing inspections. These inspections involve checking the bushings for any signs of cracks, leaks, or contamination. Fifthly, cooling system maintenance. This maintenance involves cleaning the cooling fins, checking the oil level, and inspecting the fans or pumps to ensure that they are operating properly. By performing these maintenance tasks on a regular basis, it's possible to identify and address potential problems before they lead to costly repairs or outages. In conclusion, when installing a 3-phase 208/4160 volts YY transformer with grounded neutrals, it's generally not required to run a neutral conductor with the phase conductors, as the grounding system provides an alternative path for fault current return. However, it's important to consult the NEC and local electrical codes to verify the specific requirements for your application. Additionally, it's crucial to ensure that the grounding system is properly installed and maintained to ensure safety and reliability. Remember that grounding and bonding are crucial for electrical safety. Transformers come in various types such as single-phase and 3-phase. Unbalanced loads can affect transformer performance, so load balancing is important. And finally, regular transformer maintenance is essential for reliable operation. All of these factors contribute to a safe and efficient electrical system. The absence of a neutral conductor in this specific YY transformer configuration does not diminish the safety or functionality of the system, provided that the grounding is properly implemented and maintained in accordance with the NEC and local codes. Always prioritize safety and consult with qualified electrical professionals for any electrical installations or modifications.